All right, let's get into it. Today, we're going to pull back the curtain on the invisible nervous system that runs our smartest buildings. We are talking about KNX, this incredible open standard that lets everything from the lights to the heating all speak one single intelligent language. Okay, let's dive right in.
But first, let's just stop and ask a basic question. When you hear smart building, what pops into your head? Is it just a bunch of cool gadgets that don't talk to each other? Or is it something more? You know, a building where every single part works in perfect harmony? Well, that kind of harmony, it doesn't just happen by accident. It needs a common language.
So here's our game plan for this explainer. We'll start with how this universal language even came to be. Then we'll get into its super resilient decentralized network. We'll break down how devices actually speak to each other, look at the physical nuts and bolts, and wrap up with why that little KNX logo is a rock-solid guarantee.
So, where did this all start? Well, it started with a big problem. Before KNX came along, building automation was pure chaos. It was like a digital Tower of Babel, where every manufacturer had their own system, speaking its own language, and none of them could communicate.
You see, KNX didn't just appear out of thin air. Back in the 90s, you had three big players dominating the European market. But instead of just fighting it out, they did something pretty remarkable. In 1999, they decided to join forces and create the KNX Association. The goal? Take the very best parts of all their technologies and merge them into one single open standard that was built to last. And by 2002, it was official.
Now, this merger did way more than just create a new protocol. It created a whole new philosophy for how to control a building. And it's a philosophy that makes the entire system smarter and a heck of a lot more resilient.
The heart of KNX is what's called a decentralized, distributed approach. Now, what does that mean? Well, instead of having one giant central computer as the brain for the whole building, KNX gives every single device, every switch, every sensor, its own tiny little brain. Think of it like a team where every single player can think for themselves.
And what's so cool about this is what it means in practice. A light switch can talk directly to a light fixture. A motion sensor can send a command straight to the heating system. There's no middleman, no central controller that has to approve the message. It's just direct, it's efficient, and it's incredibly fast.
And that brings us to the magic number, 0. That is how many central control stations you need for a KNX system to work. So what's the big takeaway here? If one device on the network fails, who cares? The rest of the system doesn't even blink. The other devices just keep on talking to each other and doing their jobs. It makes the whole thing unbelievably robust.
Okay, so you've got devices from hundreds of different companies, all with their own little brains. How on earth do they all understand each other perfectly? Well, the answer is a brilliant concept called interworking.
Interworking is basically the secret sauce of KNX. It's a really strict set of rules that make sure that when data is sent, it's also understood correctly by any other device, no matter who made it. And it all boils down to standardizing two key parts of the KNX language.
Let's break that down. First, you have functional blocks. Just think of these as the verbs in a sentence. They describe an action, like dim a light. Then you have data point types. These are the grammar rules. They define the exact format. So for our verb, dim a light, the data point type says the data has to be a percentage. This way, a dimmer from one company knows exactly what a switch from another company is asking for.
And this system is so incredibly flexible. Data point types can be something super simple, like a basic on or off command, or a percentage. But they can also handle way more complex stuff, like an exact temperature reading, a brightness value, or even the current date and time. It's this shared grammar that allows for really rich, detailed conversations between all the devices in a building.
Okay, so we get the logic, we get the language. But how does this all get put together in the real world? Let's talk about how you actually build and configure a KNX network.
One of the best things about KNX is just how flexible it is. You're not locked into one type of physical connection. The most common is twisted pair, that classic green cable that installers know and love. But you can also use radio frequency for wireless stuff, or even power line, which sends data over the building's existing electrical wires. And for big installations, you can use IP, Ethernet or Wi-Fi, to connect different parts of the system together. Mix and match, use them alone, it's all good.
So once everything's wired up, it needs to be configured.
And here, KNX gives you two main paths. For the big, complex jobs, certified pros use what's called S mode, or system mode. That uses a powerful piece of software to design everything down to the tiniest detail. But for smaller, simpler projects, there's E mode, or easy mode, where devices have a lot of stuff pre-programmed, making it much quicker to set up.
And you can really see the difference right here. As your project gets more sophisticated and you need more functionality, S mode is the way to go. It gives you total control. E mode, on the other hand, is absolutely perfect for those medium-sized jobs where you just want to get things up and running quickly and easily. It's all about having the right tool for the job. All right, we have covered the history, the architecture, the language, the whole setup. But there is one final crucial piece that holds this entire thing together and gives everyone peace of mind: the KNX certification.
You know, when you see that KNX logo on a product, it's not just some marketing sticker. It's a promise. It is a cast-iron guarantee that the product has been through the ringer and tested to comply with the KNX standard. It means a device from manufacturer A is going to work perfectly with a device from manufacturer B or C or D. And that is the heart of a truly open system.
And let me tell you, earning that logo is no walk in the park. A company first has to join the KNX Association, register their product, and then send it off to an independent, third-party lab for some serious testing. Only after it passes every single one of those tests can it finally be certified and get to wear that KNX trademark. And take a look at this, because it really shows how serious this whole process is. A product can't even start the certification process until the underlying standard and the official testing rules are totally locked in and approved. This makes sure every single product is judged by the exact same stable, robust set of rules. It's a system designed to guarantee compliance.
And really, it all comes down to this one simple mission: making that KNX trademark a global symbol for quality. When an installer or a client sees that logo, they know without a doubt that it's going to work.
So, there you have it. From its start as a way to unite competing systems, to its incredibly robust decentralized design, all the way to its strict guarantee of quality, KNX is the language our smart buildings speak. And that leaves us with one big question to think about. As our buildings become these complex hubs of data, how is a universal standard like KNX going to shape the very future of how we live, how we work, and how we manage energy? Thanks for tuning in.